Hello students, today we are going to study about Kepler's law. In previous class, we also discussed about Kepler's law, but that is Kepler's first law. Actually, Johannes Kepler gives three laws of planetary motion. First law is known as law of orbit, which we discussed in previous class. Today we are going to study about the second and third law of Kepler's. Kepler's second law is called law of area, and Kepler's third law is also known as law of time period. Now let's see on the board about Kepler's second law. Now, according to Kepler's second law, in first law, we know that Kepler tells the orbit of any planet around the sun is just an elliptical, and sun is situated one of its focus. Right? That means every planet moves around the sun in an elliptical orbit. That is, our orbit is elliptical, and ellipse have two focus, and sun is situated one of its focus. Now, the second law, that is law of area. According to Kepler's, if the planet moves in an elliptical path, then suppose we consider 2 points. A section which is farther from the sun and another section which is nearer from the sun. Let P is our planet and it is at position A. SA is the position of the planet from the sun. After time t, it comes at a new position B, and subtend an area ASB on sun. Now, in time t, now we take another portion when the planet is nearer from the sun, then its position, let the position be C, SC, and in the same time t, let it comes at new position D, that is SD. Here S is our sun. Then at that time, the area swept by the planet on the sun is SCSD. And according to Kepler, that's area. We can say this area, according to Kepler's second law, or the law of area, the area swept by the planet on its orbit is equal in every equal interval of time. That means if the time period of the planet from A to B and C to D will be same, then we can say the area of ASB is equal to area of CSD. That is the second law. That is the second law, Kepler's second law. That means Kepler's second law states that on its orbit, the area swept by the planet around the sun is equal for every equal interval of time. Then what is the conclusion of the second law? That means that the main conclusion is when the planet is farther from the sun than its speed. Suppose that it is the V1 when the sun is farther than the rotational velocity, angular velocity of the planet around the sun is v1, and when it is nearer from the sun, then its velocity is v2. Then actual conclusion of the second law, that when the planet is farther from the sun, then its velocity is lesser than when it is nearer from the sun. So we can say that v2 is greater than v1. That is the conclusion of the second law. Now comes the third law, that is called law of orbit. Now we can say law of orbit. According to law of orbit, if sun is at a focus and the different position, for the different position of, that means P1, P2, this is the new position of the planet, P2, that one's P3, that is P4, and that the position vector is R1, R2, R3, R4, Rn, etc. R4, that is etc. Then let R, that means R is the mean. We can say if R is the mean distance of the sun from the planet, that means R is equal to R1 plus R2 plus R3 plus plus Rn by n. If consider firstly, if capital R is the mean distance of the planet from the sun in its orbit, then Kepler tells that, according to the Kepler's third law, that means the square of the time period of a planet on its orbit is directly proportional to the cube of the mean distance between the sun and the planet. Now let again see again. According to Kepler's third law, or we can say according to the law of orbit, we can say that the square of the time period of a planet on its orbit is directly proportional to the cube of the mean distance from the sun to that orbit. Clear? Now actual conclusion we can say, T square is directly proportional to RQ. RQ is the mean distance between the sun and the planet, or we can say T square is equal to KRQ. Here K is a constant, therefore K is equal to T square by RQ. Actually this K is just a constant which is a main factors to the generation of universal gravitational constant, and this constant for every planet is fixed, is equal to a constant. So we can say that if we have two or more planets, then we can say that for the first planet R1Q is equal to, for the second planet R2Q is, for the third planet we can say R3Q will have the same value, that is R constant. So according to second law, we can say that the area swept by the planet on its orbit is equal on sun for every equal interval of time. And the third law, we can say the square of the time period of any planet around its orbit, around the sun on its orbit, is directly proportional to the mean distance between the sun and the planet. For today, thank you.